Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about linear search and string matching. Those two applications related to brute force technique that we are going to discuss. So as first, we are going to discuss about linear search. This linear search is also to be called as sequential searching. First of all, linear search is defined as a sequential search algorithm that starts at one end and goes through each element of the list until the desired element is found. Otherwise, the search continues till the end of the data set. It starts from the first element and it compares the search element with the first element. Then it goes for comparing the search element with the second element. It goes for comparing the search element with the third element. Like that, it goes up to it finds the desired element. Otherwise, it goes till the end of the list. How does this linear search algorithm works? Every element is considered as a potential match for the key and checked for the same. If any element is found equal to the key, the search is successful and the index of that element is returned. If no element is found equal to the key, the search yields no matching is found. Now, let us see the algorithm for linear searching. Now, here you can see algorithm for linear search. First, it sets a variable I is equal to 1. If I greater than n, it goes to step 7, that is prints the element not found. So initially, I definitely less than n. So if a of I is equal to x, here x is the key element which should be searched. Then we are going for step 6. Now here in step 6, what we are saying that go to print the element x is found. Suppose if a is equal to x, that is key element is found, search element is found in the list. So we are printing the element. And next, if that condition is not correct, then we are going for I is equal to, we are incrementing that value, I is equal to I plus 1. Then if I plus 1 is greater than n, then we are going to print if the element is not found. If it is not greater than n, again we are comparing that element with the search element. Like that, we are comparing each and every element. Now let us see an example for linear search. Here we have taken a list of elements. The list contains the elements 10, 50, 30, 70, 80, 20, 90, and 40. Here we consider the key element as 30. In the step 1, it starts from the first element whose index is 0 and compares key with the first element. Now, when it compared the key element with the first element, both are not matched. So here our key element is 30 and first element is 10. Both are not matched. So the search goes to the next element. It compares with the 50. Here also those two are not equal. Next, the search goes to compare with the next element, which is 30. Here both are equal. Then the key value is found and its index value can be returned. Now let us see one more example. Here you can see my key element is 41. Now I want to search for 41 in the given list. First we compared with 70. It is not equal to 41. Next we compared with 40. It is also not equal to 41. Next we compared with 30. Next we compared with 11. Next 57. Next 41. Here the key element is matched. So we found the element at the 5th index. Now if I not found the element at this index, the procedure continues till the end. So after the list, when we reached 8th, if here also the key element is not matched, then the algorithm returns the element not found. So Coming to the time complexity of linear search, the best case complexity is big O of 1. Worst case complexity is big O of n.
472-11922.
Worst case complexity is big O of n. And average case complexity is big O of n. So here, why the best case complexity is big O of 1? If the first element itself is the search element, key element. If the first element itself is key element, then this becomes best case complexity. The worst case and average case, we need to compare with the remaining elements, with the list, with the elements which are present in the list. So worst case complexity is big O of n, and average case also it becomes big O of n. So next, coming to the brute force string matching. This is one more application which can be solved using brute force approach. Now let us see what is a string. A string is a sequence of characters. So here you can see some examples for those strings. Java program, it is a sequence of characters. HTML document, DNA sequence, digitized image. All these are different examples for strings. Now coming to string matching problem. What is the definition of string matching problem? String matching algorithms are fundamental tools in computer science and are widely used in applications including text processing, data retrieval, and DNA sequence analysis. These algorithms are aimed to locate occurrences of a pattern within a larger text or string. The string matching problem refers to the task of finding all occurrences of a shorter sequence of characters, which is also to be called as pattern, or which is also to be called as a substring, within a longer sequence of characters called as text or main string. So technically, how we can define the string matching problem? Given a string T and a pattern P. Here you are given an input string T and a pattern P. The pattern matching problem consists of finding a substring of T equal to P. The goal is to identify the starting positions or indices of all non-overlapping occurrences of the patterns within the text. Right. Now you can see an example for the string matching problem. Here I have given a pattern compress and a text. Here we have given some text. So where this pattern compress is present in the given text. Here you can observe 1, 2, 3, 4, 5 positions. In 5 positions, we find the string compress. Coming to the steps, what the steps we are following in brute force approach. So here, before going to see these steps, the brute force method is also known as naive string matching algorithm, which solves the string matching problem by systematically comparing the characters of the patterns with the characters of the text, one character at a time. It involves sliding the pattern over the text and checking for matches. Now here you can see the steps to solve using brute force approach. Start at the beginning of the text, slide the pattern over the text from left to right, comparing characters at each position. If a match is found, record the starting position of the match in the text. Continue sliding the pattern one character to the right and repeating the comparison until you reach the end of the text. Repeat this process for all possible starting positions in the text. Collect and report all the starting positions where a match is found. So here you can see an example. So I want to search for the pattern AAB in the given text. So here first a matching is found. Immediately the next letter is not matching. So the search moves to next one. Here it is not matching. So it goes to the next position. Now a pattern is found here, AAB. Now here at S is equal to 2. That is at index 2, a pattern is found. So the algorithm returns index 2. Now here you can see one more example. So here AABA is the pattern and the given text is this one, right? So at what positions we find this same pattern? Here AABA. First it compares this one and it compares with the second letter, this compared with the third letter, and this compared with the fourth letter. First matching is found here. Now it goes for comparing with the first letter, this with the second letter. Here second letter is not matching. Now it leaves. Next, here first letter is not matching, it leaves. Now here goes for first letter is matching, second letter is matching, but third letter is not matching. It goes to the next position. So it continues that process, and finally it find the pattern at 0 index, 9 index, and 12 index. And I hope that you all understood how this linear search and string matching algorithms works in order to searching the element and in order to search the existence of a pattern. I hope that you all understood. Thank you for listening the session. Thank you.